Probability page 15. The Venn diagram opposite indicates the types of program a group of 40 people watched on television last night. M represents movies, S represents sport, and D represents drama. Movies, sports, drama. Okay, given that 10 people watched a movie last night, calculate A and B. Okay, 10 people watched a movie, so everything inside the circle should add up to 10. 4 plus 2 plus 1 adds up to 7, so that means A should be 3, right? And this is calculate B also. How can we calculate B given the fact that 10 people watched a movie last night? Oh, well, I guess we can use the fact that there's 40 total people, right? So 40 total people, so let's count up the people that are already in the diagram. So 4 plus 2 is 6, 7, 10, 19, 25, 37. So B has to be the difference between 37 and 40. So B has to be 3 also. Okay, so both are 3. Find the probability that one of these individuals selected at random watched sport. Okay, so that means what's the probability that the person is inside the S circle? It would be 2 plus 6 plus 1 plus 3, which would be 12, divided by the total number of people, which is 40. Okay. What is the probability that the person randomly selected watched drama and sport? So that would mean somebody that is in between drama and sport, in this fish shape between drama and sport. 1 plus 3 is 4 out of 40. Okay, 3. Watched a movie but not sport. Movie but not sport. Movie but not sport. Movie but not sport. So that would be this bit apple shape here, right? Not sport, but movie. So that would be 4 plus 3, 7 out of 40. Okay, 4. Drama but not a movie. Drama but not a movie. So that would be a bit apple shape also. It would be drama but not the movie circle. So that would be 3 plus 12, which is 15 divided by 40. 5. Drama or a movie. Drama or a movie. So that would be drama or a movie, and I assume that means both also. So it would be this figure 8 shaped thing. So it would be everything inside here. That would be 4 plus 2 plus 1, which is 7, plus 3 is 10, plus 3 more, 13, plus 12 is 25. 25 divided by 40. Okay. Moving on. So, 22H2. By drawing appropriate Venn diagrams, verify that A intersect B complement is equal to A complement. Okay. It's kind of hard to, it's easier to like do than to say, isn't it? So here's the A section, and I'm going to have an A and a B in each one. And since I have a little bit of experience now, I think I'm going to use shading. So remember, A is the left one and B is the right one. I don't want to put the label in here. It just makes it more complicated. So first I'm going to do A intersect B. A intersect B is the fish shape in the middle, right? Okay. Oh, wait a second. I'm going to save the shading for last. So, because it shows up through everything. So first I'm going to say, okay, A intersect B is the fish shape, right? And then I'm going to do the complement of that, or the opposite. So that means it's going to be everything except for the fish shape. Okay, so that's with the complement. Okay. Now I'm going to do the other one, this one here. A complement union with B complement. So I'm going to do A complement like this, and I'm going to do B complement like this. Okay, so A complement would be like this. And then I'll do B complement with cross-hatching the other way. So that would be everything except for the right circle. Okay. And then we're going to union them together. So only the things that are with double crosshatch. So only the things that look like that are the whole thing. So that would be the outside section here. Wouldn't be the fish, and it wouldn't be either the bit apples, because the bit apples are only single crosshatch, not double crosshatch. So let's see. Oh, wait a second. No. A complement union with B complement. So actually, it would also include the single crosshatch too, right? Single crosshatch is okay because it's a union. All right. So did we end up with the same thing? Yeah, because we are comparing the red I don't know what you call it, the shaded region with red shaded region with the purple region, and they are equal. So A is indeed true. Okay, let's shrink this down a little bit. Move it aside. All right, now let's do B. Ooh, B is a complicated one. A, B, C. Is that good? And then it says A, B, C. Make them a little bit bigger. A, B, C. Okay, so it's like A, B, and C. Alright, first we're going to do B intersect C. So B intersect C is this little fish shape right there. Right? Then we're going to union that with A. So A, remember, is this here. And then we're going to union it with the purple shape. So we end up with like an apple with a leaf. Okay? Now we're going to do A union B. A union B is going to be figure 8 shape. Okay? And then we're going to have A union C. A union C would be, I'll shade A union C, and it looks like that. And then we're going to intersect the two together. So when we intersect the two together, I'm going to maybe do like another shading in another direction. We're going to intersect the orange figure 8 with the shaded figure 8, and that is that would be this region here, right? It would be the circle here, the A, and it would also be this little part of the leaf. And yeah, they're equal. Good. Okay. And then last of all, let's shrink this one down too. Instead of this side. Okay, so this one's A, this one's B, and now we'll do C here. So C, this looks similar. Looks similar. A, B, and C. A, B, and C. Okay, so first one we're going to do is B union C. So B union C would be this figure 8 like that. And then we're going to intersect it with A. Intersect it with A. So A, remember, is here. So what is the region that is both orange and shaded? And so that would be, I'm going to shade it in red. So it would be this boomerang shape. And then now let's do this this one here, which would be A intersect B, which would be this fish shape here. And then we're going to union that with A intersect C. A intersect C would be this fish shape here. And then we're going to union those two together. So what area is both orange and red shaded? It would be this region, right? Oh, we're going to union it, right? We're going to union it. So it would be either red shaded or orange. Either one's fine. Hey, and there we end up with the boomerang shape again. So yeah, those are equal also. Okay. I don't really like those. They're just turn into a big mess of, especially when you're doing it with just pencil. It's kind of a pain. Okay. From the Venn diagram, the probability of A is equal to A plus B divided by A plus B plus C plus D, which is everything. Okay, that makes sense. Use the Venn diagram to find the probability of B. Well, the probability of B, the denominator would be the same as before, right? It would be A plus B plus C plus D. So we're going to write that here. A plus B plus C plus D. But the B part would be B and C, right? So we're going to put B plus C. Okay. What about the probability of A intersect B? So A intersect B would be just this part here inside the fish divided by the same denominator. So we'll put, and the fish part is B, right? So we'll put B divided by A plus B plus C plus D. Then we're going to do probability of A union B. A union B would be A, B, and C. So in the numerator, we'd put A plus B plus C. In the denominator, we'd have A plus B plus C plus D. What about 4? It says probability of A plus the probability of B minus the probability of A intersect B. So the probability of A would be A plus B over that big denominator there. Plus, and probability of B is B plus C over that big denominator, minus the probability of A intersect B, which is B, over that big denominator. So then we have A plus B plus C minus B. So that would be equal to A plus B plus C over that big denominator, A plus B plus C plus D. And that is that one right there. Okay. What a mess. C plus D. Okay. What is the connection between A union B and that thing there? What is the connection between A union B and that thing there? Okay, so the probability of A union B would be A plus B plus C, right? A plus B plus C. Did we do that? Oh, yes, this one here. And probability of A plus probability of B minus the intersection. And yeah, we did that, and they're equal. Yeah, so they're the same. They're just done in different ways. So like in one case, we are taking the union, and then the other one we add the two together, and then we subtract out the middle because it's counted twice. So actually, this is actually a formula that is always true in set theory. That if you have a union with B, then you always know that that's the same thing as the probability of the two sets separately minus the intersected part. And this works even if it's disjoint. If it's disjoint, this part here, of course, is going to be 0, and it still works. Okay? And that's it for page 15.